This is a continuation of the Chapter 12 review with problem 25. In problem 25, we're asked to find the surface area and volume of the sphere, and we're given a sphere with a diameter of 17. So let's go ahead and begin this problem. Surface area is 4 pi r squared, and that's 4 pi. The radius is half of the diameter, so that's 8.5 squared, which is 289 pi, which is approximately 907.9 square feet. The volume is going to be 4/3 pi r cubed, which is 4/3 pi 8.5 cubed, which gives us approximately 2572.4 cubic feet. Alrighty, let's move on to problem 26 now. In problem 26, we're given the circumference as 30 pi, so we're going to have to do some work to find the radius. Let's begin. 26. Circumference is 2 pi r, so 30 pi equals 2 pi r. The radius is going to be 30 pi divided by 2 pi. Pi's cancel out, so 15 equals the radius. Our surface area then is 4 pi r squared, 4 pi 15 squared, which gives us 900 pi, which is approximately equal to 2827.4, and that is square feet. Volume is 4/3 pi r cubed, which is 4/3 pi 15 cubed, and that gives us 4500 pi, which is approximately equal to 14137.2 cubic feet. Let's go ahead and move on to problem 27. Problem 27 is along the same lines as the last three. The only difference is it's in the shape of a word problem and they don't give us any pictures to use, but they shouldn't really be necessary at this point. The shape of Mercury can be approximated by a sphere with a diameter of 4880 kilometers. We're looking for the surface area and volume of Mercury. Let's go ahead and start the problem. We know that surface area is 4 pi r squared, and since the diameter is 4880, the radius must be 2440. So back over here, this gives us 4 pi 2440 squared, which gives us 2381440 pi cubic square kilometers, which is approximately equal to 74815.144.1 square kilometers. If we put in commas here, you can see it's approximately 74,815,000 square kilometers. All right, volume is 4/3 pi r cubed, which gives us 4/3 pi 2440 cubed. And I'm just going to go to the approximate value here. That's going to be 68,49650,530 cubic kilometers. And that works out to about 60.8 billion cubic kilometers. So a fairly good sized number. All right, let's move on to problem 28. In problem 28, we're given another word problem. A solid is composed of a cube with a side length of 6 meters and a hemisphere with a diameter of 6 meters. Find the volume of the composite solid. So here we're just looking for volume. And to try and draw the picture of this, it would be really ugly if I did it, but I'm going to pull up a 3D model of this. All right, so here we have a cube with a side length of 6, so this is 6 and 6 and 6, and therefore the diameter of this hemisphere is also 6. We're looking for volume, so the volume is going to be the volume of the cube plus the volume of the sphere. So the volume of the composite is the volume of the cube plus the volume of the sphere. Now that's going to be 6 times 6 times 6, which is 6 cubed, that's the volume of the cube, plus the volume of the sphere. Actually, it's the volume of the hemisphere, so it's going to be 4/3 pi r cubed, that whole thing divided by 2, because it's a hemisphere, so it's half the volume of the sphere. And since our diameter is 6, our radius is going to be 3. So that's 6 cubed plus 4/3 pi 3 cubed divided by 2. All right. This will give us an approximate volume of 272.5. Now, if you're checking your answers in the back of the book, you'll notice that the author gives 329.1, and that's because the author neglected to divide the volume of the sphere by 2. They put in the entire sphere and not half of the sphere. So the actual volume is 272.5. All right, let's move on to problem 29. In problem 29, we have a sphere that has a diameter of 18 feet, and we have an arc that is 90 degrees in measure. So we're looking at arc XY here. So this is an arc of the sphere, and we're finding the distance between points X and Y on the surface of the sphere. Now this problem is going to use the concept that the distance between any 2 points on a sphere is the arc of a great circle. So you can think of any of these arcs as being an arc of a circle that slices, that is a cross-sectional slice of the sphere going through the center of the sphere. So we find this exactly the same way we would find any arc length of any circle. We're simply going to use the central angle, and the radius of the great circle which this is an arc of. Let's go ahead and for problem 29, let's recall our formula for arc length. Arc length is to circumference as central angle is to 360. We're looking for arc length, so that's what we're going to find. Circumference is 2 pi r. Central angle, we know the central angle is 90 divided by 360. Our radius is going to be half our diameter, so arc length is 2 pi 9 as 90 is to 360. And to find arc length, we simply multiply both sides by 2 pi 9. 2 pi 9 times 90 divided by 360 gives us our arc length. We put this in our calculator and we get, it gives us approximately 14.1 feet. Now, there's an important note to make here. Since this is a sphere and we have this arc here, notice what they said. Find the distances between points X and Y. They didn't say find this shortest distance between point X and Y. So we actually have two numbers that we have to generate. The first one is this arc length, and we would be wise to go ahead and store this value in our calculator because we're going to need it to find the distance going in this direction around the sphere, around that great circle. And the way we do that, we'll call this arc length 1, and arc length 2 is going to be equal to the circumference minus the arc length we just found. So we can say 2 pi 9, which is the circumference of the circle, minus arc length 1. And that would come out to approximately 42.4 feet. So we got to be really careful when we read our problems, because some simple thing like this could really trip us up and make us miss half the problem because we only solved one part of it, not the whole thing. So a good safety tip when you're solving problems, make sure that you reread your question several times, make sure you're answering what they're asking, and that you answer completely. All right, let's move on to problem 30, but we'll go ahead and do that in the next video. So the next video will be a short segment, and I'll talk to you in the next video.